The atom is the basic building block of all matter. This depiction showing the nucleus in the center and the electrons orbiting like planets around the sun is not accurate, but as a model it helps illustrate important properties. It shows a small nucleus at the center of the atom. Within the nucleus there are two types of subatomic particles: protons, which carry a positive charge, and neutrons, which have the same mass as protons but no charge. Outside the nucleus are the electrons. The place within the atom where electrons can be found are called electron shells. Electrons are fast-moving, highly energetic, and carry a negative charge. Electrons are so small relative to the size of the protons and neutrons that their mass does not contribute to the overall mass of the atom. These three subatomic particles give each atom their properties. Since protons and neutrons have the same mass, the mass of the atom is simply the sum of the mass of the protons and neutrons. The number of protons in the nucleus determines which element an atom is. If an atom has 1 proton, it is hydrogen. If it has 2, it is helium. If it has 8, it is oxygen. This is unalterably true. Neutrons do not alter properties of an atom other than its mass, but they do play a role in stabilizing the atom. Their presence allows multiple, positively charged protons to remain tightly packed together inside the nucleus. The charge of an atom is determined by the number of protons and electrons the atom has. Each electron contributes a negative charge, and each proton contributes a positive charge. An atom with an equal number of electrons and protons has a neutral charge. An atom with more electrons than protons has a negative charge, and an atom with more protons than electrons has a positive charge. While this model helps describe some important characteristics of the atom, it is important to understand that it isn't actually what an atom looks like. Electrons do not travel in ellipses around the nucleus like planets around the sun, and like electromagnetic energy, electrons exhibit both wave-like and particle-like properties. Their exact position isn't fixed within the atom, it is better described as a set of probabilities. In this view, the orbitals become regions the electrons are most likely to be found at any given time. Another potential misconception this model may promote is the size of the nucleus relative to the rest of the atom. In reality, the electron orbitals are huge compared to the size of the nucleus. The atom is mostly open space. A properly drawn atom would show the electron orbitals with a nucleus in the center so small as to be invisible. Ernest Rutherford, the scientist who discovered the nucleus, compared its size relative to the overall size of the atom by saying finding a nucleus is like trying to find a gnat in a concert hall.